Okay. Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, August 19, 2022. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a balmy summer evening in my hometown of Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on the 1623 Studios Community Access Cable Television channel. I'm grateful for the interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists and educators, far-flung friends, family, and other curious folk. Thank you for participating. And I also might remind to make sure that you have muted yourselves. This evening, I am honored to be hosting Dr. Philip Landrigan, a pediatrician and epidemiologist with a distinguished record of achievement in the health sciences. Philip directs the Program for Global Public Health and the Common Good, as well as the Global Observatory on Planetary Health at Boston College. His research examines health impacts of toxic environmental hazards. His studies of lead conducted at the Center for Disease Control in the 1970s demonstrated that low-level lead exposure reduces children's IQ and contributed to the EPA's 1975 decision to remove lead from paint and gasoline, actions that reduced blood lead levels by 95% and increased the IQ of all American children born since 1980. His documentation of children's exquisite sensitivity to pesticides as chair of the National Academy of Science Committee on Pesticides in the Diets of Infants and Children contributed to enactment of the Food Quality Protection Act of 1996, the only federal environmental law in the United States containing explicit provisions to protect children's health. In the 1990s, he served as special assistant to the administrator of the US EPA and helped to establish EPA's Office of Children's Health Protection. From 1985 to 2018, he was a member of the faculty of the Icahn School of Medicine at Mount Sinai, where he served as chairman of the Department of Preventative Medicine, professor of pediatrics, and dean for global health. He co-chaired the Lancet Commission on Pollution and Health, which reported in 2018 that pollution causes 9 million deaths annually, and that pollution prevention is feasible, cost-effective, and saves lives. Since 2019, he has led the Monaco Commission on Human Health and Ocean Pollution. He is a member of the National Academy of Medicine. Philip's presentation today, Global Pollution and Its Health Impacts, will bring us up to speed on the kinds of pollution that continue to beset humans around the world and what we can do to mitigate this global pariah of our own making. So without any further introductions, the Zoom platform is all yours, Philip.
Bill, thank you very much. Let me go to screen sharing mode and take it away here. Oh yeah, good. So I'll go with this title here. Just let me move this little signal bar here that's in the way. Right. So the title is Global Pollution and its Health Impacts. So let me start right out with by giving you a definition of pollution. And by the way, I was telling you before the show began that I spent 1 year of my life as a medical intern at Cleveland Metropolitan General Hospital. This is a picture about 4 blocks from that hospital taken in 1968. And it shows you the kind of air pollution that we used to have in this country a half century ago. So hold that image in mind, and we'll come back to it at the end. So what is pollution? Well, in the Lancet Commission on Pollution and Health that Bill mentioned in his introduction, group of about 50 of us who worked for 2 years to produce a big report on the health effects of pollution. We define pollution as material released into the environment by human activity that harms the health of people on the planet. So we're not counting wildfire smoke, even though I know it's a hazard. We're not counting dust from the Sahara Desert, which can be a real issue in parts of Europe and the Middle East. But we focused on human-made, man-made pollution of all species. And one point that I want to emphasize right at the beginning here is the very, very close connection between pollution and climate change. And the root of them both, the root of both pollution and climate change is fossil fuels, oil and coal and gas. And combustion of the fossil fuels is, of course, the major source of all the greenhouse gases, the carbon dioxide and the methane and the other climate pollutants that rise to the atmosphere, blanket the earth, and drive climate change. Fuel combustion is also the major cause of air pollution, 85% of particulate pollution around the world, virtually all of pollution by oxides of nitrogen, oxides of sulfur. All of that comes from burning of coal, oil, and gas. Also, I think this is a piece of the puzzle that a lot of people are not as well aware of, is that fossil fuels are also the major feedstock for chemicals and plastic. Virtually all the chemicals that we use in our daily lives are petrochemicals. They're based on oil and gas, and plastics are simply a form of chemical, also based on oil and gas. And they all go together. They're all part of the same set of issues. And both pollution and climate change and also plastics have negative impacts on human health. So let me take you through some of the key findings that Bill has already alluded to from the Lancet Commission on Pollution and Health. The top line finding he mentioned is that pollution kills an estimated 9 million people per year. We produced that report back in 2018, and looking at the data for 2015. We just redid it a few months ago, looking at the data for 2019, and it really hadn't budged in the meantime. It's still about 9 million deaths around the world. There's some ups and downs. Some countries are up, some are down. But around the world, it's still a massive killer, responsible for 1 death in 6 worldwide. That's 3 times more deaths than AIDS, malaria, and TB combined, and it's 10 times more deaths than war and terrorism and all the many forms of violence that we inflict upon each other. So it's really a massive problem. Just to give you a few snapshots, this is ambient or outdoor air pollution, kills between 4 and 5 million people around the world. Some estimates say as many as 7 to 9 million. Indoor air pollution, household air pollution, which is not a big problem in the United States, except in some parts of some rural areas where people do a lot of wood burning for heat or light. But in developing countries, in India, which is where this picture is from, Central America, many parts of Africa, people use unvented or poorly vented indoor cook stoves for heat, for cooking, and create this terrible pollution that you can see here. And one of the aspects of household air pollution that doesn't apply to outdoor air pollution is that women and kids are disproportionately exposed because of what you see here, women's roles in these very traditional societies in cooking and such. Polluted water, poor sanitation, well, that's a mixture of biological waste, human waste, and chemical waste, altogether responsible for about 1.7 million deaths each year, mostly in kids. And then you have the problem of toxic chemicals that kill more than 1 million people a year. This is a picture of a lead recovery plant in Jamaica, and that gentleman is using a hammer there or an axe to break up old batteries to pull out the lead, which will then go to the local smeltery, be melted down and recycled back into commerce. And as you can see, he's got, except for the gloves, In the boots, he's got no protection of any kind, any lead dust that he generates when he whacks that battery, he's going to inhale. Also, a lot of these sorts of operations are in people's backyards, right in the middle of residential areas. So the lead spreads out and affects children, pregnant women, anybody really who's in the community there. So chemical and plastic pollution has really, it's been growing steadily over the past 5 decades, and it's become a very big problem. It hasn't received the attention that climate change has received because it's not so immediately obvious and it's not such a blatant threat, but it's quietly causing disease and death behind the scenes even as we speak. So let me give you some numbers on this. So the most recent estimates just published in Nature magazine a few months ago is that there are more than 300,000 chemicals in commerce today. Not every one of them is in consumer products, but that's the number that have been invented, produced in limited quantities at least. And these are mostly all new materials invented since the end of World War II, never before existed on the face of the earth. And of course, they're used everywhere. Some of those, I don't want to say that plastic is all bad. It's not. A lot of beneficial uses. Computers, in my field of medicine, think of flexible airways, think of endoscopes, think of IV tubing, and so on. There are essential uses of plastic, and we certainly don't want to get rid of all plastic, but we have to realize that plastic carries some substantial risks, which I'll delve into in a minute. Chemicals and plastic waste, microplastic particles, have disseminated everywhere in the environment. A few years ago, it was reported that PCBs, polychlorinated biphenyls, were recovered from the depths of the Marianas Trench, 6 miles beneath the Pacific. They're found in the Greenland ice cap. There was a recent report that microplastic particles were found in the ice on top of Mount Everest. So they really are everywhere, and they get into us. The CDC does rolling surveys through the American population, taking blood samples, urine samples, and they find between 200 and 300 manufactured chemicals in measurable levels in all of us. Yeah, to be sure, the levels are low. That's good. But the real problem, which I'll get to in a minute, is a lot of these chemicals to which we're all exposed have never, ever been tested for safety or toxicity. The poor, the marginalized, minorities are disproportionately exposed. Production is going up very steadily year to year to year. And as I said, the real kicker here is that the great majority of these chemicals have never been tested. I think most people think when they go into Home Depot, when they go into the drugstore and they take a nicely wrapped chemical product off the shelf, pesticide, lawn feeder, whatever it might be, they're assuming that somebody must have tested it. But the answer is that for the most part, chemicals have not been tested, and the experimental animals on which these chemicals are tested are you and me and our kids and our grandkids. So here's a little graph showing the growth in chemical production. This is from the years 87 to 2020, but if you took it back to 1950, the slope would be pretty much the same, really, since the end of World War II. Here's a similar graph for plastics, showing that, if anything, the rate of production is increasing. And I think what's going on there, the reason plastic production is increasing, there's 2 big factors at work. The first is that the use of coal and oil and gas as fuels is slowly going down. That market is softening as the world turns to green energy. And I think that trend is going to continue in the next few years. The new climate bill that was signed into law this week, actions in Europe, actions in California, I think you're going to see the use of burning fossil fuels decline. But at the same time, the fossil carbon industry is sitting on top of vast quantities of oil and gas that they pulled out of the ground through fracking. So they've got this issue that their traditional market is going down. They've got a lot of product. Where do they put it? And the answer has been plastics. Plastics have been referred to as the fossil fuel industry's plan B. And if you think back, just reflect back over the past 5 or 10 years, the endless multiplication of one-shot, single-use plastics. You rip something open, it's got a plastic wrapper, you throw it away, one and done. More and more plastic is going into that sort of stuff. About 70% of plastic now is single-use or short-term plastic, and very little, less than 10% of it gets recycled. So that stuff is accumulating worldwide, and it's not benign. In fact, it's toxic because plastic is loaded with all sorts of chemicals that are inserted into the plastic to make it flexible, to make it heat resistant, to make it water repellent, to protect it against fire, not to speak of coloring agents. So plastic is really a sort of a static chemical soup, and as it breaks down, all of the chemical components are released. So plastic and chemicals are really part and parcel of the same problem, and they're really very much out of control. What happens is this, that the chemical industry has some very, very smart guys, very clever chemical engineers there who develop new products. This is an old ad from the 1950s, I think, from National Geographic. DuPont, and if you can read it, it says the best things in life come in cellophane. They obviously hadn't read much about reproductive biology back then. But the point is they bring these products out, very cleverly presented, very useful products, but without giving any thought to what might be the downside, what might be the hazard. Another example is DDT. It was marvelous against malaria. Here's a picture from Jones Beach in New York City, kids running through the DDT truck. But we now know that exposure of infant girls in the womb to DDT causes breast cancer, or at least increases the risk for breast cancer 50 years later. And then here's another one of those very nice ads, this one from Union Carbide. So basically what happens is the chemicals are brought to market. The chemical industry says that they're the greatest thing since sliced bread. They market them aggressively. They don't do much pre-market testing, if any. And then 5, 10, 15, 20 years later, chemical after chemical after chemical has been found to harm the environment and to harm human health. So just to give you some classic examples, DDT I just mentioned, PCBs, polychlorinated biphenyls, asbestos, the lead that was put into gasoline, those are all classic examples of manufactured chemicals. But it's not just a historical oddity. So today, for example, we have phthalates, bisphenol A, brominated flame retardants, the PFAS chemicals that we've read so much about in recent months that are everywhere. All of these are chemicals that were brought to market. PFAS, for example, is in Gore-Tex and Teflon, and now they're getting out into the environment and into us and bound to cause harm. So let's talk about some of the harm. Let's talk about some of the health effects that pollution causes. All kinds of pollution, air plus water plus soil plus chemical pollution, is a major contributor to non-communicable disease. A quarter of heart disease deaths and stroke deaths, and close to half of all deaths from various forms of lung disease. In children, multiple diseases, so air pollution causes asthma, also causes low birth weight and premature birth. Early life exposure to air pollution reduces children's IQ. All of the chemicals I've listed here, lead, mercury, organophosphate, insecticides, and the rest. Early life exposure, infants in the womb, can cause brain injury, loss of IQ, shortened attention span. Pesticides reduce fertility in both women and men. And a class of chemicals called the phthalates, which are widely used in plastics to make them flexible, are associated with birth defects. If a pregnant woman is exposed to phthalates during pregnancy, the risk is elevated that her male child will have reproductive abnormalities. When we did that Lancet report, Lancet, by the way, probably you folks aren't in the medical world, so you won't know the name Lancet, but Lancet is the world's most widely read medical publication, comes out of London. And they asked us to do this analysis. And so when we assembled a group of 52 people who did the study, we included a couple of top flight economists. And we did that because we knew that if we wanted to change policy, it would not be sufficient simply to talk about disease and death. We also had to put a dollar value on it. And the way the economists went at it is they said it's relatively easy to compute the costs of pollution control. So for example, somebody that owns a coal-fired power plant down in West Virginia, if he's ordered by the EPA to put stack scrubbers on that factory, he can tell you pretty much to the dollar what it's going to cost to install and run that machinery from year to year. But by contrast, the cost of pollution itself, the cost of the diseases caused by pollution, much more difficult to detect because they're spread out. They're spread out in time. Some of those non-communicable diseases that I mentioned caused by pollution can take several decades to develop. Also, information on pollution-related disease is not neatly collected in one place. It's sort of buried in hospital costs. It's buried in labor statistics and so on. And it really takes some very clever sleuthing on the part of economists to dig out these costs and pull them together. But we found our economists found when they did dig into this information that the costs are quite substantial. There are healthcare costs, in other words, people that get sick from pollution and they have to go to the hospital, doctor bills, medications, and so on. There's also productivity losses, which is the economist term for the economic losses that result when somebody gets sick and is pulled off the workforce or dies prematurely and obviously can no longer work. You get a productivity loss. And these losses are huge around the world, with all these millions of tons of pollution being emitted to the environment every year. Our economists computed that it's 6% of the global economic output. That's massive. Is lost to pollution. And those are only the health-related costs. We didn't even compute the cost that result from environmental damage. We didn't have the right skill set for that analysis. And especially in poor countries, countries that are trying to bootstrap themselves out of poverty, these costs are so great that they can just undercut efforts to develop socially and economically. And there's also, no surprise, a big element of injustice in all of this. So around the world, 92% of pollution-related deaths occur in low-income and middle-income countries. And in every country, it's the poor, it's marginalized, the minorities, the kids, the elderly, who suffer the worst. So you may, I think I mentioned to a couple of you that we just published about 2 weeks ago, a study of air pollution in Massachusetts. And even though we're talking about global pollution here, I couldn't resist putting in a few of these slides. And besides all information on the contrary, Massachusetts is part of the globe. So here's a picture you'll recognize. This is looking west from above the Charles River Dam. There's the Museum of Science on the right-hand side, and in the middle background, the Salt and Pepper Bridge, the Longfellow Bridge, Mass General Hospital. And you can see the heavy pollution in the air above the city of Boston, over the city of Cambridge that day. And so the study we did was designed to look at the relationship between fine particulate air pollution, which is called PM 2.5, which means particulate matter with a mass median diameter of 2.5 microns, PM 2.5. We looked at the correlation between PM 2.5 levels and various diseases, as well as premature death in Massachusetts. And we took it down to the local level. We looked at air pollution's health impacts in every city and town across the Commonwealth. And we also looked town by town by town at pollution's impacts on children's IQ. And these are the findings. We got the most recent data we could, which typically are a few years behind reality. So the most recent data we could get for how much pollution is emitted in Massachusetts are these numbers, that there are about 938,000 tons of air pollution emitted every year in Massachusetts. And 70% of that roughly comes from motor vehicles of all kinds, 30% from stationary sources, which includes power plants, factories, and also residential heating. The average PM 2.5 concentration in Massachusetts in 2019 was 6.3 micrograms of particles per cubic meter of air. And that's, as you can see, that's roughly half, it's only half of EPA standard. So Massachusetts has quite good air. It's well below the EPA legal standard, which sounds good. But the problem is that even at average pollution levels that are well within legal standards, we have about 2,780 deaths each year across the state caused by air pollution. So we still have a ways to go here. And these include all the kinds of deaths that I showed you on that previous slide: heart disease, stroke, lung disease. In kids, PM 2.5 pollution, right here in Massachusetts, is responsible for low birth weights, asthma, and across Massachusetts for a loss of almost 2 million IQ points, which is very significant because IQ loss impairs children's performance in school. It's very closely correlated with kids' performance on standardized tests like SAT. It reduces high school graduation rates, and it has economic impacts because it reduces a person's lifetime earning capacity. And all of these effects were certainly most severe in poor minority communities, no question about that. But they were not restricted to those communities. These impacts were seen in every city and town across the state, regardless of where it is, the demographics, the racial composition, or the median family income. And here's a map of air pollution levels by county, showing that actually the highest levels are in Boston and Suffolk County, and the next highest in Middlesex, which is where I am, Newton, all the way up to New Hampshire border. And then quite benign in the middle of the state, and then a little bit of a uptick in Hampshire and in Hampton County, which is Springfield, and also in the very western part of the state, where we think what's going on there is that a certain amount of pollution comes up the Hudson Valley from New York and New Jersey and hits the western slope of the Berkshires. And we did this town by town map, and we looked at the rate. This is looking at deaths from all causes, every cause attributable to air pollution. And you can see there's several hotspots in the state. Springfield is one, right down around here. The western slope of the Berkshires, which I mentioned a moment ago, and also surprisingly rather high rates on the South Coast and Cape Cod, which again is probably due in part to a New York City effect, that the same kind of smoke that comes up from, if New York is down here, some of their pollution goes up the Hudson Valley and hits western Massachusetts, some of it tracks up Long Island Sound and hits the Cape along here. And to enable people to really access this data, because nobody, unless they're have 20/80 vision, can look at this thing and extract any information from it, but to help people to really delve into this, we had one of our students at Boston College who had dual training in computer science and public health, worked with the IT people and created a website. And you can click on this website. It's open access. It's free. There's no paywall. And you can basically see what is the impact of air pollution in the town where you live, or you can compare your town to somebody else's town and see who's better off. It's I think it's a very useful tool, and we hope, quite frankly, that it'll get people concerned, that it'll trigger political action and help us to continue to make progress against air pollution. So how do we get out of this situation that we're in globally and here in Massachusetts? Well, the first principle to keep in mind is that pollution of all kinds can be prevented. And the best evidence for that is the great progress that we have made here in the United States. against pollution. So across the USA, since 1970, which was when the Clean Air Act was passed, since that time, we have reduced air pollution across the country by 77%. That's really quite extraordinary. If you think back to that picture I showed you of Cleveland, Ohio in 1968, we just don't have that kind of bad air in the US anymore. Maybe sporadically, maybe out west right now with the wildfires. But generally speaking, we just do not have that kind of bad air. We have really made great progress. And we've done it by passing laws, regulations, incentives, enforcement, a whole toolkit that has been very effective across the whole country. And our commission's conclusion was that these solutions can be taken to global scale, even in poor countries. We felt that these solutions are feasible, and we also argue that they are cost effective, that they actually save lives. Yes, they improve health. Absolutely, they slow the pace of climate change, but they help the economy by if you clean up pollution, you prevent illness and you avert productivity losses. And those two impacts generate millions upon millions of dollars for national economies. So here's a little graph to illustrate that. This is a graph covering the years from 1970 to about 2015 or 2016. This line here that I'm pointing to on my cursor that tracks down across that 50-year period is the reduction in air pollution. This corresponds to this thing here, reduction in air pollution. You can see that air pollution levels have come down all through this period. There was a little bump between 2017 and 2021. You can figure out what might have been responsible for that, but we're back on track now. Now, we've all heard the trope that controlling pollution costs jobs, kills the economy. The data here say that that's not true, because what happened in the same time period as pollution was coming down in the United States, this pale green line here is the GDP, the gross domestic product. It grew by 250%, so that the American economy more than doubled in the same time as we were reducing pollution. It's not to say that one caused the other. I'm not claiming that at all. But what I'm saying is that it's quite possible to control pollution and grow the economy at the same time. And another reason to be optimistic about the future and further reinforces the notion that controlling pollution is going to help the economy is the incredible reduction in the last decade in the cost of producing electricity from renewables. So the cost of producing electricity from the wind has come down by more than 50% since 2010. And then the graph that I'm showing you here looks at the cost of producing electricity from sunshine, and it's come down by about 90% in a decade. If you look here, this gray-blue horizontal bar across the slide, this is the cost of producing electricity from fossil fuels, about 10 or 12 cents per kilowatt hour. And in 2010, the cost of producing electricity from sunshine was around 30 to 35 cents. Today, it's about 3 cents. So it's actually at the very low end of the cost of producing electricity from fossil fuels. And this is why the market for fossil carbon as fuel is going down. People are switching to solar because it's cheaper. And the legislation that President Biden signed into law this week is going to accelerate that trend by providing incentives for people to put solar panels on their roofs, for providing incentives to the operators of the grid to build out the grid to accommodate renewables. I think we're going to see a massive reduction in coal and oil and gas combustion in the next five or 8 years. So this is probably a good year to sell your Exxon stocks if you haven't already done so, unless they become stranded assets. Some people, of course, have said that nuclear energy would be the solution to pollution. I'd like to argue that that's not true. It is true, of course, that nuclear reactors don't produce carbon dioxide, so they don't contribute to climate change. That's a given. But they're very costly to build and operate. They can only survive with massive government subsidies. They never pay for themselves. Also, inevitably, no matter how good the design of the reactor is, it is going to produce nuclear waste. Every reactor does. That's what they do. And we've been trying since the Manhattan Project, since World War II, to find safe, politically acceptable places to store nuclear waste. And in all these years, we've not done so, which means that we're probably not going to find such a place in the next 50 years. And then there's also problems with how do you get the waste there? What about national security? Whenever you have a reactor, you've got a security risk. Look at the what's going on right now in Ukraine with the Russian troops threatening to blow up the reactors over there. And then finally, as we saw with Chernobyl, or more recently with Fukushima, when nuclear reactors blow, they may be rare, they may design them to Six Sigma and all the rest of it, but they do fail from time to time, and when they fail, the consequences are truly catastrophic and tremendously expensive. So I don't think that's the way forward. So that's it in terms of formal presentation. I thought I'll stop my screen share here at this point. I'll give it back to you, Bill. We still got a little bit of time, and if you want to do Q&A or issue an editorial, whatever, but I turn it back to you. And thank you very much.
Thank you, Philip, for a very sobering account, but with a very hopeful tone as well, given what has happened here in the United States, at least. We have several comments, which I'm going to try to bring up. Well, why don't I ask folks to unmute and ask their questions first?
Okay, let me sneak in with a bit of low-hanging fruit. The auto problem that is responsible for 70%, I think he said,
Yeah.
of is a particulate air pollution. The electrification of the global fleet. Has anybody projected out what that impact will be on that 70%? And are there any roadblocks on the way? Does it get to a point of diminishing returns at some point? Does anybody run those numbers?
Well, I can't answer it exactly the way you're asking it, but I can answer it that there's no question that anything that gets cars off the road or vehicles in general off the road is going to reduce air pollution. So, and there's multiple ways to do that. One way, although when you look at the orange line, you just shake your head in despair, but one way is to build out rapid transit and make it safe, make it affordable, make it reliable, make it inexpensive, even subsidize it, so that people use rapid transit and don't drive. Another way to get there is to electrify fleets of vehicles, MTA buses, the cars and trucks that various cities and towns use for all kinds of functions, buses, rail lines, all the purple commuter lines that radiate out from Boston could be electrified, as they are in New York City and lots of other cities. There's no reason that we have to keep running 50-year-old dirty diesel engines. I think the biggest roadblock right now, Michael, is the lack, there's two roadblocks. One is the slow pace of production of electric cars. I'm told that the waiting time is something like 2 years. And the other roadblock is the relatively sparse network of plug-in stations. I've got a daughter who has an electric car, and it's a constant challenge to find a place to plug that in because she doesn't have a proper plug-in in the apartment building where she lives. And so she has to go scouting around Greater Boston looking for little places where she can steal electricity for a couple of, excuse me, for a couple of 3 hours at a time. But I think we're going to get there. I think it's going to happen, not as fast as anybody would like, but I think more people are going to buy electric. I think the economics are going to favor electric cars. Yes, they cost a bit more at the beginning, but they cost far less to run. And there's almost no, except for tires, there's almost no moving parts, so there's very little maintenance,
Okay,
no
All right.
oil changes.
thank you.
Right. Any other questions?
You know, Phil, I keep hearing everybody talking about cars and the pollution that comes out of their tailpipe. One thing that you never hear is how much brake dust is generated from wear of the brake pads.
Yeah.
There are thousands of tons of pollutants from vehicles going into the air every day from worn out brakes, which are a consumable commodity in all moving transport, from airplanes to trains to buses to cars. That's never been looked at. And I know that they used to make them out of asbestos.
They used to
then
be
they
made
put-
out of asbestos, absolutely, yeah.
And then they have sintered material that's metallic particles. And every time you get your brakes fixed, where do you think all the material that got erased goes?
Yeah,
So I
And
never
you-
hear that.
and
The
elect,
tires wear down on the roads too. The tires produce rubber that
That's
ends up in the
correct.
environment. Yeah.
There's another thing,
and those are two things that electrifying the fleet's not gonna change.
not a
Because
bit.
those are both gonna still be there. You're absolutely right.
I think that should be thought about a little more. Electromagnetic braking, where you don't have any worn out material, might be a solution. to How do you stop tons of material? There's a real problem there that you can cure all the rest of that. It's not going to fix the problem.
Yeah, that's good. I mean, some smart young engineer at MIT could make a huge fortune on that.
You'd think. Okay, said my piece. Thanks for listening.
Yeah, important. Lynn, you had a couple of chat questions, but they've disappeared, so can you?
No, oh, okay, I just wanted to know, what were the 6 pollutants that you mentioned that?
Right, they're the pollutants that EPA calls their criteria pollutants, the ones where they have specific standards. Let me see if I can think of them all. It's PM
No.
2.5, SOx, which is sulfur oxides, NOx, which is oxides of nitrogen, ozone, lead, and
Mercury?
no, it's not one of the 6. There's one more.
sorry.
I'm sorry, I don't remember.
Okay,
But if you go to the web and look up EPA's criteria air pollutants, the list will jump right out at you.
okay.
Yeah, if I might jump in there. I have, so I wanted to ask your opinion on a number of things. First of all, I wanted to say that I don't entirely agree with your conclusion about nuclear reactors, because you used some examples there where
Me
Japanese
neither.
were careless with their reactors, and the Russians were careless in the design of their reactors, which produced Chernobyl. But you have the Canadian and the French, which produce safe reactors. The CANDU reactor, for example, uses natural uranium, which is going to produce waste anyway, naturally. So there's a role for reactors, I think, but I prefer solar and wind, but nuclear reactors could be.
I hear what you're saying, and no question, the nuclear engineers are very, very good. I was in the Navy for a while, and I know how good they were. But what do you do with the waste? Even if you control
Waste happens
every,
anyway with natural uranium. If you have natural uranium, you're gonna have waste anyway.
well, maybe.
They worked on it for the 60 years. They've ignored it. They would have solved it already. And now you can launch it into the sun and get rid of it completely.
No, you can't launch it into the sun. That takes
Why?
way too
Why?
very
What is the,
very impractical. It takes a lot of energy to get it into the sun. You'd be wasting fuel like crazy to get it into the sun. It
okay,
would, I mean,
okay.
Oh, yeah.
maybe with solar sails you could do it, but you'd have to orient them the right way. But anyway, that's another question.
The wrong way.
I wanted to ask you. I wanted to ask while I have your attention. It seems that whenever a company comes up with a new process that requires new chemicals, there's this sort of innocent until proven guilty mentality where you have to prove that the chemicals are dangerous before they are banned, which I was thinking of neonicotinoids, for example, which are in pesticides and they kill bees, and they're banned in European countries, but not in Canada or the US. Maybe, I mean, it's been talked about that this should change so that they have to, when they come up with this idea of using new chemicals, they have to prove that they're safe before they use them. I mean, what do you think of that?
This is something I've thought a lot about because I've spent a lot of my life working on chemical toxicity. And I think the system is totally backwards. The way you described it is absolutely right. Chemicals are considered innocent until proven guilty, which means they come to market with very, very little in the way of pre-market scrutiny. They're put into products, they get out there, and it's only after people have been exposed and disease or environmental damage is discovered many years later that action is taken to get rid of them. And I think it's a broken system. And it's backwards. I mean, you would never buy a car without test driving it. You would never buy a house without having an engineer do a careful inspection. And yet we put new chemicals out with essentially no scrutiny. It's interesting. There's one class of chemicals that gets very carefully regulated, of course, is pharmaceuticals.
Right.
Under FDA, a pharmaceutical chemical has to be proven to be safe, and it has to be proven to be effective. And the whole ritual of clinical trials and so on that we became so familiar with the COVID vaccines. So we know how to do it, but in the case of all the so-called industrial chemicals or commercial chemicals, we've not done it. We've just let them go. And I think that's going to have to change. There was an attempt made by the Congress in 2016 to get it right, but the legislation that came out was only an incremental improvement over the failed legislation that preceded it. And we really need a very fundamental revamping of chemical regulation. No question about it.
We have a question from Jerry Halberstadt.
Yeah, thank you. I thank you for putting this on. Phil, your work and your colleagues is absolutely tremendous, and I urge everybody to dip into your report on Massachusetts. I found it very helpful. Lynn is one of my colleagues. A bunch of us have been fighting against a fossil burning peaker plant that's being installed a mile from where I live.
And that's in Peabody, right?
That's in Peabody.
Yeah.
And I working from your material and from what we know already, may give us the impetus to do what you basically hoped people would do. As I read your description of why you went ahead and did this, in order to basically incite people like me and Lynn and others to make a hue and cry about the degree of pollution that we're living with and try to do something about it.
Yeah.
And physicians and scientists too rarely step out of a very narrow role. And I am so glad that you and your colleagues have done this work. From what I've seen and tried to understand of it, first of all, there's Peabody with a black because of the number of deaths or the percentage of deaths. And there's no obvious reason for it because the towns surrounding us don't show that. And so one of the things we're going to try to do is get public health people to dig into that and try to understand, and maybe it's just lack of reporting, or, we're not seeing the degree of illness that you would expect. It doesn't show up in the charts. And so my guess is it's probably there, that people aren't getting treated or it isn't getting properly reported.
And that peaker plant's not on stream yet, right?
No, but they're rushing to do it because they've got a deadline.
Yeah.
And if I may, there are a couple of additional things that can be done that the group of advocates have been playing with. One is we have to change the stuck in the mud monopoly attitude of the power plants. that don't want to give up fossil fuel, and ISO New England, which regulates that and decides what fuel can come online. It seems like, fossil fuel forever. And
Let me tell you a quick story about ISO New England, which is the independent system operators who run the New England power grid. Just about 3 months ago, they made a decision to exclude renewable energy from the power grid. So you might ask, why would they make that decision? The reason is that renewable energy is too cheap. It would actually undercut the cost of electricity produced by gas or oil or coal. And so these folks in their wisdom said, well, we're going to make taxpayers, ratepayers pay more for their electricity so that we can basically subsidize the fossil fuel industry. There ought to be a popular uprising about this. A couple of us had an op-ed piece, I should say, in the Boston Globe a couple of months ago. If you want to Google it up, it's called "Every Electron is Not Neutral." And
Lynn and I are going to be on the picket lines, and because it's crazy. It's absolutely crazy. It's
No, but-
wrong in terms of electricity. It's wrong for pollution, and for God's sake, we're burning up the planet. I mean, let's get real about it. And so there's a lot that needs to be done for transitioning, and we should have started 50 years ago, because it would take several decades, but we don't have that time. We've got a few years, and I guess I'm not the only one that's sort of in panic about where we are. And so as I say, Phil, you've done a great job, and bring these basic informational facts to the public is so important. And I hope other people will pick up the ball in other parts of the Commonwealth.
well, thank you for the kind words. I'll just, you mentioned our website, and the most prominent feature of the website is the town-by-town map that you can click on your town or compare your town with another town. That feature is in there. But also on the website are a series of recommendations, what people can do individually in terms of their own purchasing, what towns can do, what the Commonwealth, the state of Massachusetts can do, and what the federal government can do. We basically worked with a lot of friends and colleagues to assemble that list. Most of it's cost effective. The major impediment to controlling pollution really is not technology, but in some places it is, but mostly it's politics and it's economics.
Bill, I want to commend you for a great talk. I thought I caught you in an error, but I looked it up and you were right. When you said that Lancet was the most widely read, about 8 or 10 years ago, New England Journal surpassed them in both impact factor and global circulation, mainly because they give it away free to 80 countries. But the latest numbers for the last few years prove you right. So
Richard Horton, the editor of Lancet, is this incredible entrepreneur, and I'm sure he checks those numbers every night before he goes to sleep.
sure.
I have a question having to do with going from local to global. You said that you have recommendations at the federal level. I was wondering whether you might have recommendations for the United Nations.
We have made recommendations to the UN. We've been to the World Health Organization and to the UN Environment Program, which are UN agencies. And the basic pitch we've made is that it begins with the observation that 92% of pollution-related deaths are occurring in poor countries. And so it stands to reason, if you want to reduce deaths in those countries, you have to look for leverage points. Obviously, you can't just pour money in endlessly. That's not going to work. But the trick is to identify smart people in those countries who can be trained to to target the problems and go after them. And the toolkit that we've used so successfully in this country since 1970 is a toolkit that, with modification to fit local legal systems, can be applied in any country. And some developing countries have been doing it. Mexico actually has done quite a good job in getting rid of air pollution in Mexico City. It's still bad, but it's a hell of a lot better than it used to be. China has picked up on our numbers, and they have passed legislation and set targets and timetables for reducing air pollution. They're beginning to achieve a downturn. Africa is going up. India is still going up. But it's not for lack of knowing. There's lots of smart engineers in India, but the government is continuing to subsidize coal-fired power plants.
Right. Well, I guess this is the last chance for any further questions.
Well, I just wanted to say one thing. You didn't mention nanoparticles, which
true.
are sneaking into our lives undetected and unnoticed.
Yeah, well, when fossil fuels are combusted, visible, micro, and nanoparticles are all produced. And most of the regulatory and research up until now has focused on the PM 2.5 because we've got good technology for measuring this stuff. It's going to require another generation of monitors to measure nano.
But
Everybody in the field knows that they're there. They understand that it's an unexamined issue, but that's about where it stands.
But they're also put in things like cream cheese and face creams, and so it's not
Yeah,
not
those
air
are,
pollution, but it is a pollutant that gets into our bodies.
that's right. Those are manufactured nanoparticles. They're
Yes.
in cosmetics too. Yeah, you
Yes.
mentioned face cream, yeah.
This is Norman. Philip, how have you been so fortunate to find funding to do all this great work? Because clearly you don't get funding from ExxonMobil or DuPont.
That last statement is true. So this study was supported by two sources. The external funding came from the Barr Foundation, which is a private philanthropy based in Boston down on near Rose Wharf. And also we got some core funding from my institution, from Boston College, which supports the bulk of my salary and also supported the development of the website that I mentioned. So there are sources of funding out there. There are various philanthropic foundations. The National Institutes of Health is now putting more money into studying the health effects of climate change.
Yeah, I just wanted to mention there's one chemical that has an effect. It causes more air pollution. I'm not sure how much more. It's called glyphosate. It's used in Canada. I think it's used in the US as well to kill deciduous trees because they want the conifers. The conifers give them softwood lumber for economic reasons. They like softwood lumber. But by killing the deciduous trees, they make forest fires worse because the deciduous trees can block flames fairly effectively, and the fires don't spread as well. So I don't know how big an effect this is, but this creates more air pollution because of that.
Yeah, it also, so glyphosate, which is marketed under the name of Roundup,
Yeah.
you can pick it up at Home Depot. It's the world's most widely used herbicide. In 2015, the World Health Organization determined that it's a probable human carcinogen, causes lymphoma, and there are big lawsuits in the courts now, people bringing suit against Monsanto and Bayer Chemical about glyphosate. Yeah, that's an
I think it's also contributing to air pollution. I don't know how much, but
yeah, it's an indirect effect, but yeah, absolutely, yeah. And you mentioned one of my other favorite chemicals a few minutes ago, Bill, neonicotinoids. So New York State is about to ban most uses of neonics.
excellent. Yeah.
Yeah.
Philip, I might end with my own question, and that is having to do with what could students do to contribute to the science? I mean, I noticed that you have air pollution levels, a map town by town. You know, what pollutants are being measured, and could students equipped properly contribute to that effort on a more granular level?
Yeah, no, that's a great question, because lack of granularity is one of the obvious shortcomings in our study. There are about 20 air monitors across the Commonwealth supported by DEP, but there's 353 towns, I believe. So clearly, there's not a monitor.
Not enough.
Huh?
Not enough.
obviously not enough. And it's not high tech anymore. And a great student project would be to set up an air monitor at their local school. And
Do you know a good source for purchasing?
well,
such a-
that's let me get a name for you. I don't have one at the top of my head,
Okay,
but they are out there. There are portable monitors. Let me ask a colleague who is more in the air monitoring space than I am, and I'll get back to you on that, Bill.
okay. Well, I see it's now 8:06, so I think we've had a wonderful round table here. And I want to really thank Philip once again for being willing to come and share your knowledge and the knowledge that your group has gained. And it's so worthwhile being shared.
Well, thank you. Thank you for the kind words. Thanks, everyone, for your attention and the great questions.
Thanks for your presentation.
Okay. And thank you all for participating. Makes it lively.
Indeed. Okay. Yeah,
Thank you.
cheers. Bye-bye.
Bye.
Bye.
Night, everybody.
Good night.